So this section is going to be on quadratic functions, but before we talk about quadratics, I just want to back up for a second and review polynomials in general. So polynomial means many terms. Would look something like this right here. And so one thing to note is that the exponents have to be whole numbers. So some of your homework problems will ask you if it's a polynomial or not. You're looking for only whole numbers, which have to be not negative. So something like x to the negative 3 makes it not a polynomial. X to the half or a square root would make it not a polynomial. It's got to be nice and simple like this. We look at polynomials a lot because they're some of the simplest functions that we have. They don't have any weird asymptotes or holes or gaps in the graph. The domain is all real numbers. They're pretty nicely behaved functions. And so some of the key features we're going to look at are the degree and the leading coefficient. So degree is the highest exponent. So for this one here, that would be 5. And then the leading coefficient is the coefficient, the number in front of that term. So you find your degree, and then you look at that term, and the coefficient is the leading coefficient. The reason we call it the leading coefficient is because normally that leads the polynomial. It's at the beginning. Typically, we write them in standard form. We write the highest exponent first, and then in decreasing order of exponents for the terms. And so normally the degree term comes first, and so that coefficient leads the polynomial. It's in the front of the polynomial. All right, so the simplest kind of polynomials would be lines. So a horizontal line, y equals 5, has a degree of 0. It doesn't have x to the anything in it. If you've just got x without an exponent, that's x to the first. So y equals 2x plus 7 has a degree of 1. So either a degree of 0 or a degree of 1 will make it a line. So those are the simplest kind of polynomials. We already looked at those, so we're going to jump up now to quadratics. If we have a degree of 2, if we have x squared, it's a quadratic. And so there's two different ways that you'll see the equation of a quadratic written. It can be written in standard form, like we talked about, starting with the highest exponent and then going down, or we might write it in vertex form, because quadratics are, of course, going to be parabolas. We hopefully know that already, of course. X squared gives you that nice U shape, and so the key thing for a parabola is the vertex, the center point. So the vertex, we're talking about this point right here in the middle of the parabola. And so vertex form is going to show you the vertex nice and easily. This is in kind of the shift form. It shows you a shift right or left and then a shift up or down. And so those shifts show you where the vertex would be. So x minus h, if that was like x minus 5, that would go with x equals 5. This h right here is going to be the x of the vertex. And then the plus k, that's going to be how much it shifts up or down. That's going to be the y of the vertex. So we call this vertex form because it shows you the vertex directly. Standard form doesn't show you the vertex quite as directly, but there is a way to find it from standard form. The vertex, the x coordinate of it, is actually at negative b over 2a. Negative b over 2a. Hopefully you feel like you've seen something kind of like that before, starting with the opposite of b being all over 2a. That's actually the first part of the quadratic formula, because we know the vertex is going to be in the middle of the x-intercepts. And so one x-intercept is going to be at negative b over 2a plus the square root of b squared minus 4ac, and then the other x-intercept is going to be at negative b over 2a minus the square root of b squared minus 4ac. So the vertex is right in the middle. It's the part of the quadratic formula before the plus or minus. All right, now this is going to be one important thing to note. The value of a is exactly the same in both forms. So notice we're using the same letter here. All the other letters, except for x, of course, are different, but the a is the same because this number, that a, is going to be the same in either form. And then you probably remember, if you've got a positive a, if you've got a positive leading coefficient, the parabola opens up. Negative leading coefficient, the parabola opens down. Now we've got something called an axis of symmetry. The parabola is going to be symmetrical from the left to the right. So there's this line going straight through the vertex that we call the axis of symmetry, where it's symmetrical on either side of that vertical line. All right, so let's try to find a bunch of these things for particular quadratic functions, and we'll graph the parabola. Let's see. Oh, looks like I used part D twice. Sorry about that. We'll make that part E there. All right, so we'll start with the vertex. And so if we're starting in vertex form here, we're just going to use that nice formula to find the vertex. So we're going to say x equals the opposite of b, so -2. And then over 2a, you don't see the a right there. So of course that's going to be 1. X squared, same thing as 1x squared. So opposite b over 2a. So -2 divided by 2, that's going to be -1. So that's the x of the vertex. Of course, the vertex is a point, so we need to find the y. All right, so let's think about this for a minute here. We've got the x. If only there were some sort of equation or rule or formula that when you knew the x, you could find the y. Well, that's exactly what the function is, right? I always try to make this joke here. Some people kind of get stuck here for a minute, thinking, "Well, how do I find the y? What do I do now?" That's what the function's for. The function is the rule, the equation, the formula that when you know the x, it tells you the y. So to find the y, I'm just going to take x is -1 and substitute it in here. I'm going to find f of -1. So -1 squared, of course, is +1. -1 times -1. So we got +1 here, and then that will be -2, and then -8. And so 1 minus 10 looks like I'm looking at -9 here. And so my vertex is -1, -9. All right, so if I've got my vertex, it should be easy to find my vertex form. All right, so let's write out the vertex form here. So if we look at this, so A, how do I find A? Well, that's the key of what we said here. In both forms, A is the same. So whatever A was in standard form is the A now. So if the A was 1 here, then the A is still going to be 1 there. So I don't have to write it. I mean, you could write it if you want to. You could put a 1 there, but we don't need it. And then we've got x, okay, so it's -h. So we need minus -1 here. So minus the x of the vertex minus -1, this is going to be +1. Just like usual, x equals -1 goes with x plus 1. Okay, and then let's see, now the k, it's just plus k here, so you could put plus -9 or -9. Okay. I'll stop for 1 second and take a look, see if you notice anything missing there. I'm trying to write the equation of this quadratic, the equation of this parabola. Well, that means it has to have squared on it. Without that squared, that would have just been a line right there. So don't forget those squares. That's a common thing that people, when they're going too fast, they're careless, they miss that, but that's very important. If you want this to be a quadratic, if you want it to be a parabola, it has to have that squared on it. All right, so then the axis of symmetry. So the axis of symmetry is a vertical line. Well, we know the equation of a vertical line always starts with x equals. Okay? Well, if it goes through the vertex, then it has to be x equals the x of the vertex. So it's just going to be x equals -1. So basically, whenever you find the x of the vertex, you can just copy that right down, and that'll be your axis of symmetry. All right, now for the x-intercepts, we want, so x-intercepts y are 0. If you're on the x-axis, then you haven't gone anywhere vertically. So x-intercepts y is 0. So we want to set the whole equation equal to 0. And then, of course, this one factors nicely. And so we get those x values. Technically, we should probably write them as coordinate pairs. There we go, right? So we found all this stuff here, so we can throw these things on the grid to graph it. So we've got -1, -9. The -10 is at the edge of the grid. -9 is right there. And then -4, 0, and 2, 0. if you wanted to show the axis of symmetry, you can maybe put a dashed line here. Here's your axis of symmetry right there. That divides the parabola in two. If you wanted more nice points here, you could use your y-intercept as well. So if you plugged in 0, you'd get -8 for the y-intercept. And then anytime you have 1 point for a parabola, you've got another. You could go on the other side here of the axis of symmetry and get that mirror image of that point. I mean, this is probably plenty of points for now. If you wanted more, parabolas follow, you might have heard a 1, 3, 5. So from the vertex, you could go over 1 and then up 1. And then when you go over 1, now it's up 3 more. All right. I like to remember 1 squared is 1, 2 squared is 4, so you go over 2 from the vertex and up 4, and then 3 squared is 9, so over 3, up 9. But either way, you can just keep going 1, 3, 5. Okay. But normally we don't need all these points, but just to show you, if you wanted a really accurate graph, look like that. Okay. And we do get a parabola opening upwards, which is what we should have expected. We had a positive a right there. Notice another way you could have figured out your vertex right here. If you wanted, you could have found the x-intercept first. You could have found these points first, and then we know the vertex is in the middle. And so you could have said, well, what number is in the middle of -4 and 2? You could kind of count backwards and figure out, well, x equals -1 is right in the middle. So that's where the vertex would be. All right, let's try one more here. Also got to show you a couple other things that can come up. So this one, if we want to find the vertex, again, we do this -b over 2a. Just remember, it's the opposite of b, so it's -4. And then here our a is -1. So we're going to have +4 over -2. That'll be -2. And then find our y. If only we had something that when we knew the x told us the y. That's this equation right here, right? So we'll plug this in. Now be careful when you do this though. So it's -2 squared -4 times -2 plus 1. You can't do a change here, right? You can't just make those negatives cancel out. You've got to do the exponent first, -2 squared, that's +4, and then put the negative on it. So this is -4 plus 8 plus 1. So -4 plus 9, that will be 5. So your vertex is -2, 5. So then once you've got that, you can write the vertex form really nicely. Okay. Now remember, vertex form, we look at this up here, vertex form starts with the A. Don't forget that A. All right. How do we find the A? Just copy it down. This A right here was -1, so the A down here is going to be -1. Whatever the A is right here, just copy it. Okay. And then x equals -2 goes with x plus 2. Don't forget your squared. It is a parabola, quadratic. And then the y of the vertex is 5. If we want to go up 5, we need a plus 5 here. So there's our vertex form. And then we're still following the same directions here. We're trying to find all of these different things. So if we want the axis of symmetry, it's just x equals the x of the vertex. Now what about the x-intercepts? If you try to do -x squared minus 4x plus 1 equals 0, well, it doesn't factor. Well, that would be annoying, right? That would mean you'd have to either do completing the square or the quadratic formula. Okay? But actually, there's a better option that's going to save us some of the work. We used this equation at first to try to find the x-intercepts. There's a better option. What about this equation? this equation, actually, half of the completing the square work is done. There's actually a way you can find vertex form using completing the square. If anyone wants to know about that, you can email me or Google it. I find it's less accurate. Students make more mistakes that way. But you could get to this using completing the square. And then if I use this equation, I can find my x-intercepts a lot more easily. Let's use this. Let's say negative x plus 2 squared plus 5 equals 0. Well, now I can just subtract the 5, isolate things here. Negative x plus 2 squared is negative 5, divide by the negative. Then I can square root both sides to get rid of the squared. X plus 2 is plus or minus root 5. And then I can just subtract the 2 over and get my answers. Of course, when we subtract the 2 here, usually we write the negative 2 first, plus or minus root 5. So if the standard form equation doesn't factor, it's often a lot easier just to use that vertex form to find your x-intercepts there. All right, so if we want to graph this now, and we've got negative 2, 5. That's 1 point right there. I mean, if you want to try to figure out these x-intercepts, we know square root of 5 is more than square root of 4, less than square root of 9. So it'd be between 2 and 3. So negative 2 plus 2 point something, it's going to be 0 point something. It's going to be somewhere in here. Negative 2 minus 2 point something. Negative 4 point something, be somewhere in there. But really, probably if it's ugly like that, I wouldn't worry too much about graphing the x-intercepts. You could use the y-intercept. If you plug in 0, you'll just get that 1. So 0, 1 here. Look on the other side of the axis of symmetry. We can put that in there to help us here. So we're 2 away from the axis of symmetry there. So if I go 2 away from the axis of symmetry there, I get another point. Okay. I can also use the pattern, 1, 3, 5, or 1 squared is 1, 2 squared is 4. The biggest thing, though, is make sure that you have the vertex. And then because we've got this negative, then we know we have to have this parabola opening down. Usually, as long as you have the vertex and know what direction the parabola is opening, usually that's enough for your graph. But those would be some more points if you wanted them. So why don't you try all these things for this third example here. Again, still doing all those same directions right there. Find the vertex form equation, axis of symmetry, x-intercepts, and then take a look at what the graph is. Go ahead and try that one for this third problem here. All right, so your answers should look like this. Vertex should have been 1, 9. Vertex form equation, make sure you had that negative 4 there, and it's not just the negative, it's the whole a value that copies over. So make sure you have that negative 4 in front of your vertex form equation. And then your x-intercepts here, it actually did factor. So you could have factored, or if you were thinking that didn't look like it was going to factor nicely, you can use the vertex form equation right there. Just here, you would have to actually do the addition subtraction. You couldn't just write 1 plus or minus 3 halves. You would have to actually tell me what is 1 plus or minus 3 halves and figure out those two numbers. So now let's take a look at this problem here. We want to find the equation of the parabola. Notice it just says an equation. It doesn't say what form we have to use, so we can pick our form. Well, if they tell us the vertex, how about we start with vertex form? Okay, so what we want is y equals, now we don't know the a though, so I'm just going to have to leave that as a right now. And then it's going to be x minus 4, and then again, x minus 4 goes with x equals 4, but then negative 1, let's just shift down 1, so I need the minus 1, okay? Now I'm missing something here. Do you see what it is? It's that squared. Don't forget that squared. That's very, very important, okay? All right, so that's almost our answer. We're just missing that darn pesky a right there. Well, we've got some more information we haven't used here. We've got a point, an x and y. So let's plug in those x and y. 7 equals a times 2 minus 4 squared minus 1. And then now we've got a is the only variable, so we can solve for a. So that's the key. We plug in the vertex into the h and k from vertex form, and then plug in this random point into the x and y. All right, so 7 equals a times, this is negative 2 squared minus 1. And so 7 equals a times 4 minus 1. Now be careful here. Sometimes people get tempted. Don't get tempted by that 4 minus 1. You're not allowed to do that, right? PEMDAS says multiplication would have to happen first. So you can't do that subtraction. You might find it helpful to rewrite this. Write this as 4a. Put that number in front so you won't be tempted. And then, of course, you'll know to add the 1. 8 equals 4a, so that then we can find a equals 2. All right, now that's not your answer, though. I didn't ask you for the value of a in the problem. I wanted the equation of the parabola. Don't forget to go back and actually write that all out. Y equals 2. I found that a value now. X minus 4 squared minus 1. All right, so number 2 will be the exact same process. Why don't you just go ahead and give one a try yourself. And then number 3, I'm giving you the x-intercept. See if you remember how to write the equation from the x-intercepts. Go ahead and give those a try. And there are those answers for you to check here. So you should have gotten 3/4 for A on this problem too. And then for this one here, the idea is if we know the x equals solutions, we can go backwards to write the factors. So on this, we want to start with vertex form because we knew the vertex. X-intercepts are related to the factored form. So we just use that factor form, and it just said an equation. So just to go ahead and left it that way. All right. Now also notice though it says a parabola. This actually wouldn't be the only answer here. If you think about it, if I tell you these x-intercepts here, there's not only one way to draw a parabola through those x-intercepts. So we found this one here, but what about if we had that one? What about a parabola opening down? Or what if we had kind of a stretch or shrink kind of thing? What if it was fatter or skinnier? There's lots of different parabolas. There's actually an infinite number of answers here. So when we do our Canvas quizzes, I'll probably have to specify something to make that not be the case, because what we could have added in here is a leading coefficient, or multiplied in technically. Okay? We could have, you could have said y equals negative pi times x plus 3 times x minus 5 if you wanted to. So I'll probably have to say in the Canvas quiz that we want the leading coefficient to be 1, and then we wouldn't be able to put those kinds of things there. But otherwise, there would have been infinite answers. You could have said y equals 1,522, x plus 3, x minus 5. But most of us, of course, will just give that answer.